So hello guys, continuing with the functions. So yesterday we saw what is passed by value using the swap example. So it was easy again. We are just seeing a very quick brief revision of it. So we have a swap A and B, and after swap we are passing 100 and 200. We have a void function here that copies the value of A and B into X and Y. Even if it is A and B, it does not matter because they will be copied into another separate memory location. So whatever operations is having on the copies of A and B. So A gets copied to X and B to Y. We do the swapping. So basically X and Y are swapped in the function, but the changes don't get reflected into the main code. The reason being we had passed both 100 and 200 in the form which is called as pass by values. We were passing actual values and not the base address or by reference. All right. So whatever changes you actually did in the function and not in the main. Fine. So today we will see pass and swap by reference. So in reference, basically, you can just take a feel that because in this code, values before in main is m equal to 100, n equal to 20. And values in the swap function is 200 and 100. Basically, it shows that it is swapped. And values after swap in the main is m is equal to 200 and n equal to 100. Now, how did this happen? Right? So you can see here I'm passing m and n, but along with their address. So let us go to the drawing board and try to understand what things are basically happening here. That here, when you swap in the function, basically the changes are being reflected into the main. So let me just try a small piece of code. Control C, Control N, Control V. Yeah, there is someone whose mic is on. Kindly turn off your mic. Just a minute. Let me just try to keep the same example as yesterday so that you can actually link here. Ampersand A, ampersand B. Change rename symbol to A. So temp equal to star A equal to temp, star A equal to star B, and star B is equal to temp. And then value basically is this will be star A. Expected declaration. Okay. Let me guys just try this code once again. Yeah, 100, 200, 200, 100, and 200, 100. Fine. So now if you see, this is basically identical on the lines of the code that we saw yesterday, right? So you have AB as 100, 200. Now just look at line number 14, and this becomes passed by reference address, right? So when you have swap A and B here, you have actually swap ampersand A and ampersand B. What did we see yesterday? We had a swap function in which we are passing only A and B, right? So let me just copy this line and paste it here so that you can understand the difference. Here you are only passing the values, right? You are only passing the values, and in swap ampersand A ampersand B, you are passing ampersand of A. We saw yesterday that when you have an ampersand, ampersand specifies the addresses, right? So let me just go back to the drawing board. Once again, we will do a quick revision. Suppose A is equal to 100. Let's say this is an integer. So in the memory, there will be some box which is representing A. And what is ampersand of A? This is the address at which memory location A is stored. And star ampersand A means value at ampersand A. So star, you can remember, star in C is basically known as value at, right? So value at address ampersand A. So value at 6422,300. So which is nothing but 100. So basically A is also equal to 100 and ampersand star A is also equal to 100. So this were our basics of pointers that we did yesterday. Now let us come back to this main code, which is swap ampersand A and ampersand B. Here A is 100, B is 200. So let us do one thing. Right, so we have, let us do A is equal to 100 and B is equal to 200. Let me make A as 100 here and B as 200. Right, now let us change the pen color and have their base address also. So ampersand A means some memory address, let's say 6422. I'm just assuming some simple address. And ampersand B is 64, we can say, let us say 26, because both are integers, so separation of 4 bytes, right? So this basically is the address. And as I said, star ampersand A is also equal to 100. Okay, let me use a different pen color. And let's say pen color is this, right? Star ampersand A is equal to 100. Similarly, star ampersand B is 200. So you can see this both are basically the same thing. This is the address and value at the address. Fine. Now this is equal. This is good. I think A is 100, ampersand star ampersand A is 100, ampersand A is the address. Right. Every system, when you execute your code, will have a different address. Let me just erase this. Now see what we are doing. In the swap function, we are passing ampersand A and ampersand B. Right. So in the swap function, let me change the pen color. In the swap function, I am passing ampersand A and ampersand B. So indirectly, what it will become is, what was ampersand A? Ampersand A is 6422. So you are passing 6422 and 6426. Right? So you can see here, instead of values, now you are passing addresses. Right? This and this are addresses. Right? These are addresses. Now what will happen, as we say, when we run a function, the main execution is paused. So what we will jump? We will jump to the pair where function is defined. Right? Now you just see the function definition, void swap. Now since you are passing an address, you actually need to collect it via star A. Because see, if you see in this example also, 6422 can also represent an integer, a normal integer, right? 6422 can also represent an integer, or yesterday we saw 6422,300. That is also a normal integer, right? So as to avoid confusion, what does the compiler say that? So whenever you are passing an ampersand A, right, it is an address. Address is also a number. So you collect it in the form of star A. Now this tells the compiler that whatever was being passed in the swap function, so basically it is a address. Treat it specially. It's an address, not a simple value. Right? Get the point? So whenever you are passing an address, you need to collect it star A. That means you are specifying to the compiler that in this variable A, the things that will be stored represents an address. It represents an address. So let us see how the function will basically run. So I will say here void swap, it is integer star a star b, right? So star basically is to specify that the A will store an address. So what will happen? This 6422 will copy to A, 6426 will copy to B, right? So indirectly what it will become? Void swap integer star of 6422 integer star of 6426, right? So now you can see I am passing an address to the function. I am passing an address to the function. I do not know what is stored at 6422. I do not know what is stored at 6422. I do not know what is stored at 6426, right? And now our standard logic, right? Temp is equal to star A is equal to star B, and star B is equal to temp, right? Now basically what is happening here, now if you see this memory diagram, what was A? A is 6422. So basically temp is equal to star 6422. And what is star 6422? Just change the pen color to a lighter color. Star 6422 means we have studied value at the address. So star 6422 basically is star of 6422, which is nothing but 100. Get the point? Similarly to this only, because ampersand A is having 6422. So star of 6422 is 100, right? So basically temp will be equal to 10, because 6422 is the address and the value at that address is 10. Sorry, 100. I'm sorry, it is 100, right? It is 100. Similarly, when you write star A is equal to star B, what does that signify? This is too light a color. Star A is equal to star B. So what is star B? Star B means star of 6426, right? 6426. So what is star at 6426? The value is 200, right? And this basically, now star A will be equal to 200. So what basically happens here? This becomes 200, right? Star A means the value which is at the address A, right? The value which is at address A will become now 200. Similarly, temp had the value 100. So what I'm saying, star B is equal to temp. I'm not saying B equal to something. Star B means B was having an address 6426. So star of 6426 is equal to what was temp? Temp was 100. So what is 6426? 6426 is this address. Star of this means the value to be stored at this address. So now it becomes 100. So now you saw in pass by reference or pass by address, we are actually passing these addresses. Similar to the example on Flipkart that we saw yesterday, right? So Flipkart, if he knows that, okay, I need to deliver this phone to Sachin, he can directly go and to Sachin's room. But if he does not know who stays in that room, he directly says, okay, this parcel is meant for A102, whoever is in that room. Similarly, what I'm saying here, I am not saying to the compiler that please swap 100 and 200. I am saying that swap the values that are stored at locations 6422 and 6426. We are passing addresses here. So for example, if I just copy this code, address, so let me just print the address of A and B, right? Let me just print this address. So now you can see the address is 6422 and 6422 Fine. So in this case, you can see that whenever see in the sense I am writing here ampersand A, ampersand B. So what is the value of ampersand A? So address, it is 6422 300, 6422 296. So basically, what will happen in this case when you actually pass this? So this will pass at in this fashion, right? This will pass here in this fashion. Okay, and now let us see what is the value. So value of A is star A. Because it's an integer, we specify D here. D here is ampersand star B, right? So now to make you realize that, okay, this is here address of A and value of A is 100 and 200. Okay, in the swap function, let me just do a slash and so now you can see address is 6422 296, value of A is 100, value of B is 200, and in the swap function it has becoming 200 and 100, and which is getting reflected into the main. Why? Because here you passed the address of A and the variable B. So basically it is not dealing with values, it is dealing with a reference to A. Why it is called reference to A? Because ampersand A is pointing to a reference to A, right? So let's say you have a Flipkart parcel for the room A102, right? On the first of the month, you place an order, and the order delivered is to be expected on 7th of that month. And let's say for some reason you had to shift your quarters on the 3rd of the month, and now some new guy comes in the building on 4th. So that Flipkart delivery will actually go to the 7th on the same house and deliver it, right? Of course they will do name verification, but the point I'm trying to make it, your address never changes, right? The delivery address does not change. So whatever you are passing here you are passing ampersand A, that means you are passing address. Fine. And now when you are passing the address in the function definition, you need to mention that, okay, this is a special address, so we need to specify star, which indicates that, okay, the variable A basically holds the address, it is not a value, it holds the address. And then, as you know, star of address, basically that means value at that address, right? So basically it means indirectly it means star of 6422 300. That means value stored at this address. So what is the value? Value is 100. So 100 goes into temp, right? So this is basically known as pass by address or pass by reference, right? So whenever you do pass by reference, basically the changes are happening into the main. And let me show you if I online GCC compiler. Yeah, online GDB. Right, so this is an online compiler. Let me try to run the code here. See, now you can see this is also an online compiler, right? The same output is coming 100 and 200. Fine. And now you can see the address of A here is a different address, right? In my code, it was 6422 300. So this address depends on compiler to compiler. Whatever free location was there on the machine, it will actually give you that free location. But important thing is, whenever you are passing an address, you see before swap, the value was 100 and 200. In the swap function, it was 200 and 100. And after swap, the value is 200 and 100. Fine. So you can just try it on different compilers. So don't worry when you run on your machine and you are getting a different address. It is not important that what is the address. What is important here is that basically the changes are reflected into the main. See, again, this is a different address. Fine. So every online site will have a different address. See, 14072 something 8496 here. This is a different address. But in all the cases, the changes that are happening are also reflected into the main. That is the main concern that I wanted to express here, which is known as pass by address or pass by reference. A is a variable of int type. right? But how it is storing an address? Because it is a pointer variable. So it's a good question. So let me just tell you. So see, A is holding the value 100, right? A is holding the value 100. But what we are passing in the function, we are passing ampersand A in the function. We are not passing A into the function. Now, since we are passing ampersand A into the function, we are actually passing the address here, right? Now that you are passing the address, because if you see these values, this is also an integer value. To make the compiler realize that, okay, this is an address, not a simple value, we use the pointer notation. So star A means A is not a simple integer value, right? A is a pointer variable. And now when we place int here, so what does that mean? Okay, I forgot to tell you about this point. So when we are saying that, okay, let me change the pen color to black. Okay, so I'm writing it here. So when we say integer star A, that means A will hold the address, right? A will hold the address. Star A will give me that value, right? And what does integer specify? This value that is stored at this address is of type integer, right? Is of type integer. So for example, when you say ampersand A, right? So wherever A is stored, right? A is basically an integer. So wherever 100 is stored, that memory address is given here. So this 6422 basically it's an address. Star means A is holding an address, but A is holding an address of the data type integer, right? A is holding the address where the value stored is of type integer, right? So if I write it here float, of course the program execution will be wrong, but it means that A is holding an address, the value on that address is a float type, right? So this is the thing when you do pass by reference. Let me just exit this. Okay, so class, we can have a break for 5 minutes. Just try to go through this code once again, try to get a feel of it, right? So we will return back at 11:30. So hi, I think Prakar, a very nice question from you. Is it possible to swap two numbers by swapping their address? A good question, but logically you cannot exchange address, right? So for example, it is just like if you are staying in 104 and 10, your friend is in 108, you don't swap the rooms, you only swap the person staying in the room. So memory locations are fixed, right? So a computer memory location, for example, if I can show you in an Excel file, right? So you can just assume something like this is a memory location 0 and this memory location is 4, right? So let's say you have 100 bytes of memory only, right? I'm just saying, okay, let's say this is, okay, this is equal to, right? So you can see, assume that your computer has 60 bytes of memory, right? So in this 60 bytes of memory, what happens? Whatever values you put here, only these gets changed. For example, this was 100 and this was 200. So this can never be changed. Like these are sealed by the compiler and the operating system, right? Because assume you have a hard disk of 20 terabytes or 1 terabyte. You cannot exceed the space of it. You cannot reduce the space of it. It is fixed hardware based, right? So the answer to your question is it is not possible to swap addresses because they are fixed memory locations, right? So this is all about passing by value and passing by address, right? In passing by address, we use ampersand a because ampersand represents the address. We collect it using a pointer variable. We specify the data type from which it is collected. Similarly, for pass by value, we are just passing on the values, right? You can refer, for those who have installed Dropbox, you can actually refer to function 7 because it is an identical copy of what we wrote for the swap by value, so that you can see the minute differences. Fine. So the next chapter we will actually see is basically recursion. I think we were in the third chapter. Yeah, this is recursion factorial and recursion Fibonacci. Okay. So recursion is a concept of functions. wherein a function calls itself, right? So for example, if I open the program swap by value, so here what you are seeing is swap a comma b, right? So swap a comma b, you can see the control basically goes out of the code. The control basically goes out of the code. So main function is calling the swap function. So if we go to our drawing board, right, let us go to the next page. So we have void main, we have swap a comma b, and then we have a swap function, and here is the logic. So what is happening? The main function executes and then comes to swap. Swap comes outside the main, and then swap returns to the main. So this is 1, this is 2, and this is 3, right? So the main is calling the swap function, and the swap returns to the main. This is a normal execution. Now what happens in recursion? So recursion is a methodology, it's a programming methodology wherein a function calls itself, right? So now what do I mean by function calling itself, right? So let me just give you a very small example of it. So let us say, I mean, I'm keeping a very small program. I mean, we are not even having something here to do. We are just displaying the value of. So this will be the simplest example of recursion. Int y is equal to 10, right? So, and then we are calling swap here. Let us see the output for here, right? And let me just clear the screen so that it appears std lib.h system cls semicolon run code. You can see the value is coming as 10. So if I call the swap function 3 times, the output will be displayed 3 times, 10, 10, 10. And now let us do one thing. So this I am doing it. See, I am printing the value of y, and then I'm calling the function swap. So here what is happening? Main is being called. Main calls swap. I reach here. So let me just say I reach here. Function is over. I return back here. Then I call swap. I reach here, print, go back, and so on and so forth. So you can see I am jumping between main and swap. I am jumping between main and swap. Now let us do one thing. I'm calling from the swap, and in the swap function, now you can see this will actually print 10 infinite times. You can see it is going on printing. Why? What is happening here? See, we have studied that a function returns to the point where it was called. So now you have main, you are calling swap, and in the swap function, you are doing a printf and then calling a swap function, right? So now let me change the pen color. So you are calling the swap function. So function begins from main always. You are calling the swap function for the first time. So it comes here. This is step 2. It executes. So it prints the value 10, right? See, now it will return to the main only when this function executes. Now what is happening? See, this is a swap function, and I'm calling the swap function from within the swap function. I'm calling the swap function. So this becomes 3. Now what happens? Again it executes swap function, so it prints the value 10 again, and now again it is called, right? So this becomes step number 4. right? Again it prints the value 10, it again calls the swap function. So you can get a feel that the swap function will be called infinitely. Seema, CLS is a Windows command to clear the terminal. So before executing the command, I just use CLS so that the terminal can be cleared. Even if it is not given, there is no issue. So now you can see the swap function will be called infinite times and it will never stop, right? Here it has stopped because the modern day compilers beyond a certain point automatically stop the program, assuming that it has entered into a state of infinite execution, right? It has entered a state of infinite execution. During your program also it may happen, your code may run into an infinite time. Just press Control C. So when you press Control C, it's a forced break to the program. It's a forced break to the program. So basically this phenomena wherein a function is calling itself, remember the lines, function calls itself, this is called as recursion, right? The function calls itself is known as recursion, right? So this philosophy, now you will ask why it is used. We will just see, because there are some programs when you study data structures, the recursion actually helps you to write a very short and a sweet code, right? So now let us see how do you compute a factorial of a number using a recursion approach, right? So let us go back to our drawing board, and here we will see how to compute a recursion of a number, right? So let's say if you have a number 5 whose factorial you want to calculate. So what is the factorial of 5? 5 into 4 into 3 into 2 into 1, right? Which is equal to 120, 20, 60, 120. Yeah. 5 factorial is 120, right? So now you see if the number is n factorial, so what you will do, n minus 1, n minus 2, right? So it will become n minus, right, up to basically multiplication of 1, 2, 3, 4. I mean, we assume like if it is a kth term, right, n minus 1 up to it will go to that point, right? So n minus this becomes, so n minus it will be n minus 1, right? Till that point it will be the multiplication. So it is a multiplication of this. So now let us see, if I want to calculate the factorial of 5, what I can write it, factorial of, sorry, it is equal to 5 into factorial of 4. This is a correct statement. How can I write 4? It is the 4 into 3 factorial. How can I write 3 factorial? 5 into 4 into 3 into 2 factorial. How can I write 2 factorial? 2 into 1 factorial. Now we know that 1 factorial is 1, right? So this is 1. So basically what is happening, 5 into 4 into 3 into 2 into 1 factorial is 1. So now you can see 5, 4, 3, 2, 1, and which is equal to 120. So instead of basically directly multiplying all numbers, you can see I wrote 5 factorial in terms of 5 and 4 factorial. I wrote 4 factorial in terms of 4 into 3 factorial. I wrote 3 factorial as 3 into 2 factorial. I wrote 2 factorial as 2 into 1 factorial. And then finally I knew that 1 factorial is 1, so I returned 1, and then I get the complete factorial, right? So now just remember this logic and we will be able to see how the recursion works, right? And in the previous example you could see that I am calling the swap function infinitely many times. Now why did this did not stop? Because I did not have an exit condition, right? So basically what is happening here is, there has, for example, if you write a while loop while I is less than 10 and you just print the value of I, right? And let's say the initial value of I was 100. So 100 is less than 10, you print the value. 100 is less than 10, you print the value. So it again becomes an infinite loop. So with the recursion, what happens is you need to specify something that can actually exit the loop, right? So let us come back here. So now you understood this logic, right? So if I write this in terms of n factorial. So this is equal to n into n minus 1 factorial, right? This I can expand as n minus 1 into n minus 2 factorial. This I can write as n minus 1, n minus 2, n minus 3 factorial, and so on, right? So you can see that every step I am getting an individual multiplication, and towards the end it is a factorial. And finally I will get n minus 1, right? So this is equal to 1 factorial, which I know is 1, right? Let us go to the next slide and just see how this program actually works. So now here I am asking the user to enter a positive integer. Let me just run the code. stdlib.h. Okay, so basically I have missed out something. Probably last time I was calculating something else. Let me just see. Printf factorial of n is this. If n is greater than 1, then it is n into factorial n minus 1. Else, enter a positive integer and I am passing the value n. Yeah. So factorial of 5 is 120. And now we will see how is the function. Oh, the output is also very nicely printed. So I will just show you what happens here. So you entered a positive integer, which is n, which is basically 5, right? So factorial of 5 basically is equal to factorial of 5. So I'm calling a function here and I'm passing the value n is equal to 5, right? Now the value n, which is 5, gets copied here, right? Now what I'm saying, see, printf starting each factorial function with n, right? So initially what was n? Initially n was 5. So starting the factorial function with n is equal to 5. So n is equal to 5. Now what is the loop? If n is greater than 1, right? N is greater than 1, right? So basically 2, 3, 4 and up to the range of integers, right? So this loop will falsify when n is equal to 1, right? So what I'm saying, I'm just doing a printf here. This printf is just for, getting you to get a feel of the factorial. In if part, why? Because I am in the if part. In if part, call factorial function with n into factorial of n minus 1. That is percentage d into factorial percentage d, where this is equal to n and n minus 1. Forget about those things. Just see, if n is greater than 1, printf anyways does nothing. What I am returning? I am returning n into factorial of n minus 1. Can you relate it to this? I am returning n into factorial n minus 1. This was same 5 into factorial of 5 minus 1, which is 4. So what will happen here when I am returning factorial n minus 1? What was the initial value of n when we entered the loop? It was 5. So what will it will return? Factorial of 5 minus 1. So what is the value that is getting into the function? 5 minus 1 is 4. So 4 comes here now, right? So now you can see from the factorial function. Yeah. Someone please unmute yourself. Okay, so we are returning 5 into factorial of 4. Now you can see I'm calling the factorial function from the factorial function, right? You can see the factorial function exists from this line to this line. So from the factorial function, I am again calling the factorial function. So what it will pass? 5 into factorial of 5 minus 1, which is 4. So now what the value of n becomes? N now becomes 4. 4 is greater than 1, true. So now what it will return? 4 into factorial of 3, right? So now you can see initially it was 5 into factorial n minus 1, which is 4. Then I started the function with 4, so it becomes 4 into factorial of 3. Then it becomes 3 into factorial of 2. I hope this is making sense. Then when you pass, it becomes factorial of 2 into factorial of 1. So when n is equal to 1, so when n equal to 1, the if will falsify because it is only checking for greater than 1. So when n is equal to 1, I come to the else part, and in the else part I am returning 1. So you see it returns 1. So where will it return? It will return to the point where it was called. So factorial of 1 is returning 1. Where it will be returning? It will be returning to the place where it was called. Right? So let me just show you an example on the drawing board so it will make sense to you. So for factorial, I am writing the function as f only so that I don't have to repeat again and again. So we have integer n, right? So f integer n, if n is greater than 1, then what I am doing, I am calling n into factorial of n minus 1. Else what I do, else I return 1. This is basically the synopsis of my function if you see in brief. Right? So initially n was having a value of 5. So let us see, we will try to use as many color coding as possible. Let us start with the blue. So when n is 5 here, 5 is greater than 1, true. So what are we returning? Right, so let me just write 1, 2, 3, 4, 5, 6, 7. Right, so line number 4, we are returning 5 into n minus 1. This is the function 5 minus 1. So we are returning 5 into function of 4. Right, so this function calls itself. Now what is happening when I'm passing 4? So this becomes 4. Now this is 4 is greater than 1. So 4 is greater than 1. So now we have 4 into, right? So we will have 5 into, so this function expands as 4 into f of 3, right? Because 4 into f of 4 minus 1. So it becomes f of 3, right? Now let me just erase it. So now what is happening? F of 3 will again come here with the n equal to 3. So n will be 3. 3 is greater than 1, right? So what it is returning? N into f of n minus 1. So it is returning 5 into 4 into n into f of 3 minus 1 is 2. Again it returns here. So now this time n is equal to 2. 2 is greater than 1. So this is true. So it is returning 2 into f of 2 minus 1. F of 1. So now it will return again n is equal to 1 in this case. 1 greater than 1. So this is falsified. It will come to else part. Else what is it doing? Else is returning 1. It will return to the place where the function was called. Where it was called? The function was called at this point. So what it returned? It returned 1. Right? So you can now see what has happened. 5, 4, 3, 2 and 1. It has returned to this particular point, and this basically is nothing but the value 120. One important thing whenever you do recursion is to remember that the function should be designed such a way that it has a exit clause. The function should be designed such that it has an exit clause. Now I will just show you the factorial.gif. So you see this is how it is happening. Factorial of 6 is 6 into factorial of 5, 6 into n into factorial n minus 1. It goes on to factorial 1, right? So factorial 1 returns 1, right? So now 2 into 1 is 2, then 2 into 3 is 6. So this basically is the steps that are basically taken when you do something on recursion. So on normal cases, recursion needs to be avoided at all cost because it is too much of overhead. Because if you see, for such a factorial function, we had to do so many function jumps. And between the function jumps, basically functions make use of stack array structure. Stack is a data structure basically. So it remembers the values which were previously called. So just you can ignore as of now. But recursion is heavy on the program and the memory, right? So avoid recursions, but there are some cases where recursion makes you write a very simplistic code. Fine. So this was all about recursion, right? So I think class we can stop for today. For as a homework, what I'm saying, in the same Dropbox folder, there is a program for Fibonacci series, right? So you know what is Fibonacci series? So Fibonacci is just a very simple code. So you have initial values 0 and 1, and the next value is the sum of previous two values. So 0 plus 1 is 1. So next value will be 1 plus 1, which is 2. Next value will be 1 plus 2, which is 3. Then 2 plus 3, which is 5. 3 plus 5 is again 8, right? So you can see in this case, the whole logic of recursion is if n is 0, return 0, n is 1, return 1, the first values, else return the sum of previous two values, right? So let it run for first 10 values. So you can see for the first 9 values, the output is 0, 1, 1, 2, 3, 5, 8, 13. 5 plus 8 is 13. So this you can do as a homework. It's a very simple code and you can understand what recursion is. Just try to do some practice of recursion. It's not a very difficult concept, but important thing is at some point you need to return the values so that the function comes to a exit, or else the function would continuously run and it will never terminate. One last very small piece of code is the operator which is known as Sizeof. As I said, this integers, floats and all are mostly system dependent, whether you are using a 32-bit system or a 64-bit system, right? So a good way to determine that is to basically make use of the operator Sizeof, right? So here I have taken integer, float, double, character and int, which is an array. So now you can see the operator name is Sizeof. So Sizeof, and in the bracket you write the name of the variable. It will give how much bytes it is occupying in the memory. So let me run the code again. So you can see size of integer is 4 byte, float is 4 bytes, double is 8 byte, character is 1, and the roll number array is 100 bytes. Why? Because integer takes 4 bytes and our array is of length 25. So 25 into 4 is 100 bytes. So again, a very small piece of code, but Sizeof is required many a times, and it can come as a quiz question also in the midsum examinations. Okay, guys, so we are stopping the video. I think there are no doubts in the chat box also.